Okay, homework from section 4.5b. This is U-Substitution involving definite intervals. So the first step stays the same. We want to rewrite in terms of parentheses. So once we have it as rational exponents, we see that we want the u value to be x cubed plus 1. So d over dx equals 3x squared. Dx simply 3 over du over 3x squared. We make our substitutions. 2x squared stays. X cubed plus 1 gets replaced with u to the 1/2. Dx gets replaced with du over 3x squared. The x squared cancels out, but we have to keep track of the 2/3. Pull that in front. Okay. So now we can find the integral. 2/3 u to the 3/2 over 3/2. So we have our indefinite integral 4/9 u to the 3/2, but we have to evaluate between our upper and lower bounds. So we have to convert our lower bound to be in terms of u. So our lower bound initially was 1, x equals 1, and now we're going to plug 1 into our value for u. So u is x cubed plus 1, so replace 1 in for x. So we get 1 cubed plus 1, which is 2. So our old lower bound is 1, but now our new lower bound is 2. Our initial lower bound is 2, so plug 2 in for x, our assignment here, and u is equal to 2 cubed plus 1, so 8 plus 1 is 9, so we have our lower bound being 2, upper bound being 9, so now we're going to evaluate our antiderivative with our new upper and lower bounds. Plug in upper bound first. 9 goes in for u, and then minus, then 2 goes in for u. Okay. Simplify here. 9 to the 3/2 becomes 3. 2 to the 3/2. This is really 2 cubed, which is 8. Square root of 8 is 2 root 2. So we can simplify up to a certain point, but to produce our answer in terms of exact value, we have to leave it as root 2. So 12 minus 8 root 2 over 9 is our definite integral. Okay, 77. We can see that our u value is 1 plus square root of x. So to find the derivative, I'm going to rewrite this in terms of rational exponent. Find du over dx. So 1 goes to 0, but x to the 1/2 becomes 1/2 x to the negative 1/2, which we can rewrite as 1 over 2 root x. Cross multiply, dx equals 2 root x du. We make our substitution. Square root of x stays. Parentheses gets replaced with u, so we have u squared. Dx gets replaced with 2 root x du. Square root of x cancels out. So keep track of the 2, so pull the 2 in front, and the so we have 2 over u squared. Okay. We want to go through power rule, so bring the u up back to the top. So integral of 2u to negative 2. Find the indefinite integral, so we have 2u to negative 1 over negative 1, so negative 2 over u. But this is a definite integral problem, so we have to evaluate this with our upper and lower bound. So we have to convert our lower and upper bound to be in terms of u. So our assignment is u is equal to 1 plus square root of x. So for x equals 1, replace 1 in for x, so u is equal to 1 plus square root of 1, which is 2. Plug 9 in for x, so u is equal to 1 plus square root of 9, which is 4. So our new lower bound is 2, our new upper bound is 4. So we're going to evaluate our antiderivative using our new upper and lower bound. Plug in 4, we get negative 2/4, minus, then plug in your lower bound, negative 2 over 2. So negative 1/2 plus 2 is simply positive 1/2. Okay, 79. Rewrite our problem in terms of rational exponents. Our u value will be 2 minus x. Find the derivative. We have du over dx equals negative 1, dx equals negative du. We make our substitutions. 2 minus x gets replaced with u to the 1/2. Dx gets replaced with negative du, but the x minus 1 doesn't cancel out. So we look at our assignment. U is equal to 2 minus x. We rewrite it in terms of x. X equals 2 minus u. So we do change a variable. So x gets replaced with u, 2 minus u minus 1, which reduces to be 1 minus u. distribute the u to the 1/2 through, but we don't want to forget to keep track of the negative that's produced from the dx equals negative du. Distribute through, we get u to the 1/2 plus u to the 3/2. Go through power rule and combine the terms, simplify. So now we have our antiderivative, but we have to find our new lower and upper bound so that we can evaluate to find the definite integral. Our assignment is u equal to 2 minus x, so for x equals 1, we're going to plug 1 in for x, so 2 minus 1 is 1. So our lower bound did not change. Our lower bound started at 1 and it ends at 1 as well. For x equals 2, we plug 2 in for x, so we get 2 minus 2, which is 0. Now, we have to be, this is something that we have to be careful about, is that whatever lower bound we start, whatever number we get, it will remain a lower bound. So x equals 2 is the upper bound, but our new upper bound is 0. So even if your upper bound ends up being smaller than your lower bound, you're not going to switch. Okay, so whatever 2 turns into, it will remain as the upper bound, even if it ends up being smaller than your lower bound. Okay, so now upper bound first, plug 0 in, that's just all going to go to 0, so we can now take care of the lower bound, minus f of a, so plug 1 in for u, so we're going to get negative 2/3 plus 2/5, distribute the negative through, so we get positive 2/3 minus 2/5, common denominators, and we're going to get 4/15.